two metal plates are separated from each other by a small distance, 5 millimeters. And we do know the voltage across the plates. Voltage is 18 volts. And we want to figure out how fast a proton moves going from the positive plate to the negative plate. So the proton starts at rest next to the plate, that's positive, and then will be pushed and attracted across to the other side. Once again, since these are parallel plates, they are set up so that there's an electric field between them, and the electric field has a constant value. We then have a kinetic energy and electric potential energy conversion using the conservation energy. In this case, it's electric potential energy, when it's located here, equals kinetic energy when it gets to the other side. So electric potential energy can be calculated by taking the charge of a proton, multiplying it by the voltage, and setting equal to then 1/2 mv squared. So that's kind of the general thing we're actually going to do here. So let's find the electric potential energy first. So electric potential energy is then going to equal 1.6 times 10 to the minus 19. This is the charge of a proton. And we'll multiply that by the voltage between the plates, which is 18. So electric potential energy then has a value of 2.88 times 10 to the minus 18 joules. We're now going to set that electric potential energy equal to 1/2 mv squared to find the velocity of the proton just before it gets to those plates on the left. So we'll say 2.88 times 10 to the minus 18 equals 1/2. Now we'll use the mass. 1.67 times 10 to the minus 27 times v squared. I'm going to put a vector hat on that. I should do that on this one as well, so you don't get confused. That does not mean voltage. That means velocity. So the velocity of the proton just before it gets to the other side is 58,700 meters per second. Now again, there's still a little bit of confusion usually with the 1.6 times 10 to the minus 19 versus the 1.67 times 10 to the minus 27. This value here is the charge of an electron using the QD equation. And this is the mass of a proton. So the charge of a proton, mass of a proton. And the mass right there for the kinetic energy is 1 mv squared. So hopefully that helps you understand the difference between those two.